So first we will see what is the definition of a set. This is a very basic thing, but anyway I will start with the definition of a set. I name this as definition number 1. Set. A set is any collection of definite distinguishable objects. Or a set is a collection of well-defined objects. It should be well defined. What are the characteristics of the elements in a set, and it should be defined well. That is a basic definition of a set. And hereafter in our studies we denote, set is denoted by capital letters A, B, C, like this. Capital letters denotes the sets. Set, and small letters denotes the elements of the set. This we should keep in mind throughout this study. And if A belongs to the set, we write, suppose an element A belongs to the set A, we write A belongs to the set A. And if an element does not belong to the set, we use this symbol. A does not belongs to the set A. These are not very basic, but anyway we will be using these notations throughout. This is a symbol for element and not an element. What is a subset? A set is said to be a subset of another set, say B, and is written as A is a subset of B, or B contains the set A. Both are same. If all the points of A are points of B, every element of A is an element of B. So like this, generally you would have seen it. Here, suppose this is the set A. Sorry, A is a subset of B. No? Suppose this is a set B, and something like this. This is a set A. A is a subset of B. So every element of A is also an element of B. And this one is nothing but B difference A, the set of all elements of B which does not belong to A. For this also we are going to see the definition. So this is a basic definition of sets. When you say the two sets are equal, this is very important thing we are going to use throughout the study. Two sets A and B are said to be equal If and only if and only if, this is a symbol we use, the sort of notation, if and only if A must be a subset of B, and also B must be a subset, B must be a subset of A. Both this inequality, this set relationship must satisfy. Only then we say that A is equals to B. And if suppose A is a subset of B, and you find that if suppose A is not equals to B, that is B is a subset of A, you cannot prove it, then we say that A is a proper subset. A is a proper subset of B. This is a definition we use. This is for subset, proper subset. And what is an empty set? For this I don't want to give the name for definition, simply I will write it here. What is an empty set? Everywhere we will be using it. Empty set. It is a set which has no elements. It is a set which has no elements in it. So it will be written like, suppose B is an empty set, we will write like this. Simply empty brackets, or sometimes B is equals to pi. The symbol is, don't put 0 and all here. 0 is an element. So like this, empty braces means it's an empty set. It has no element. It indicates that it has no elements. And hereafter all the sets, the convention we are going to use is something like a rule. We make it. All the sets, what we are going to discuss, A, B, C, so on, are subsets of a big set named as a universal set S. We call it as universal set, always. So if I define any set A, B, C, anything in the discussion, it is understood that there exists some universal set inside which this set belongs. And suppose this is a universal set, what is S difference A is the complement of A. Complement of the set A. Related to S. Very important. Related to S. And we write the complement of A as simply the symbol A dash. These are the notations we will be using it. And very important result is, this is clearly known, any universal set is nothing but A union its complement. For example, this is the universal set, and suppose A is my subset of this set A, and this set, this empty space here, we call it as S minus A, we call it as the complement of A. So what happens if we union these two parts, I get S.